Hi guys, welcome back to another lecture series on artificial intelligence. In this video, we'll be discussing about logistic regression. In the last video, we discussed about a regression analysis in which we discussed like linear regression, non-linear regression, which were based on continuous value problem. Now, what if the problem comes of discrete value problems like binary, like classification? So suppose we were going for predicting whether we were going to predict like how much temperature will be there. Now think of a different situation, like we have to predict will there be rain today or not. So two different situations. Did you just go through that? Right? So two different situations. We'll be discussing about this situation, second one, like yes or no. Here it was continuous, now it will be yes or no, 0 or 1, like in computer binary system it happens. So we'll be discussing classification regression, actually you can say that, right? So let's see what's the agenda for today. So for today's session we'll be having what is logistic regression, the difference between logistic and linear regression, the maths behind logistic regression, like what functions, what mathematical tools we use for this regression. We find the hypothesis function, that is relationship, so that we find the predicted values. Then we go ahead and find out what is the cost function for this particular system which we are talking today, and then gradient descent, which will help us again to perfect our algorithm. And then finally we'll be discussing about applications of logistic regression. So that's all guys, this is the agenda for today. We'll be discussing what is logistic regression. So as explained, in the binary classification what happens, we have to classify things, and for classification we can't use continuous thing like linear regression. So here also regression is just a name, but it's just a binary classification using mathematical tools. Simple logistic regression is nothing but a statistical tool for binary classification or multinomial classification, like many classes, right? So suppose we have temperature, we have humidity, and we have wind. This data set is available for these things, and out of that we'll use certain mathematical functions to find out that there will be sunny or rainy. So we'll find out basically probability of it, and we'll manipulate this probability to find out will there be rain or not, will there be sunny day or not, right? Okay. Logistic regression, we have, if you take the blueprint of this, it will come out to be x1, x2, and x3 are our attributes, and theta 1 and theta 2, theta 3. In the previous video, also in regression analysis, you saw we have certain parameters like theta 1 and theta 2 and theta 3 or theta n up to. So, these parameters help us in finding out whether we are sad or happy, right? So, logistic regression is used for that. Let's see how what is difference between linear and logistic regression. So linear approach models the relationship between dependent variable and one or more independent variable. So dependent variable and one or more independent variable, find the relationship between that. And logistic regression, what is this? A statistical model that predicts the probability of an outcome that can only have two values, right? Statistical model that predicts the probability of an outcome that can only have two values, yes or no. It's statistical model basically, right? That predicts the probability of an outcome that can only have two values, only two values, basically binary, used to solve regression problem, right? Continuous value problem, but it's for binary value problem. So basically I told you also that it's a statistical model. It's basically mathematical function, nothing more than that. Calculate the possibility of an event. Here we used to do what? We used to find out what will be the change if we change independent variable, what will be the change in dependent variable. Outcome is continuous, here outcome is discrete. We use S curve or sigmoid function here. Now we're discussing about a statistical model. So we use some functions, and that function is nothing but sigmoid function. Here, which function you used to just function with straight line y equals to mx plus c we used to do, or either quadratic equation. What are the like we used to predict the GDP of a country. We used to predict product price. What will be in future product price as the magai is increasing. Yeah, okay, and predicting the house selling price, score predictions, and all, and predicting whether email is spam or not is the work of logistic regression. Yes or no? Okay. So predicting whether the credit card transaction is fraud or not. Yeah. How do we classify that? We'll see how we do that. We'll use certain type of functions. Sigmoid function, you must be aware of it. We should like suppose I go to certain bank and I have to just think of should I go to that bank or not. How do you think of that? Will that bank give me a loan or not? Why if that bank is very reliable bank, like it has many resources, and I have also the that amount, that properties which I can lease for loan and all, right? Then there comes the possibility that yes, that they will give the loan, but how to formulate it mathematically, that is what we'll see here, right? So linear regression graph, you can see this graph is what it goes from 0 to 1. This is linear graph. So predicted y can exceed 0 and 1 range, right? So here what happens, this range can be more. Like if you change x more, it range will keep on increasing. It's not always 0 and 1, right? But in case of logistic regression, it will be always lying between 0 and 1. That is the actual range here, right? So this range is 0 or 1. So how do we model that? So suppose y equals to, this was earlier our function, y equals to, if you remove this part. Now what we'll do, we'll find fraction of it, y by 1 minus y. So it will be fraction, and we likelihood you find out, right? Probability, and then take log of it. That is what functions will be, that function we'll be using. Now we can simplify this function. So value of y will be always between 0 and 1. And this will be certain decimal values. 0 to 1 it will be 0 point something, 0.58, 0.89. So we'll take some threshold value like 0.5 or 0.8. So below 0.8 suppose it is there, then we'll take this to be 0, and if it is above that we'll take it to be 1. So threshold you have to define. We'll see how we'll define the threshold. Currently we'll be taking threshold at 0.5, right? Okay. So let's see maths. Now we have come to a point where we'll be having what function shall we using it. So that function you saw, this one, if you simplify this function, you will get this as hypothesis. Theta is nothing but b0, b1, which you were saying. Here you see beta 0, beta 1 and something like that. So it's theta 1 we have taken as a, right? So h theta x is nothing but predicted value, that is y predicted. And yi, that is nothing but actual y, that is not predicted y, this is predicted y. So this will be function, this will be giving some probability to us based on this parameters, theta transpose. Why do we do theta transpose? Now question comes, because we have to multiply it. Suppose it's theta 0 into x0, theta 1 into x1. So how do you multiply? We take transpose, and then x is this vector and this vector. So you have to study vectors for that, right? If you tell me, I'll make separate video on that. Just comment right below. So this is the cost function. Now we'll be justifying this cost function. Says this cost function is here minus log of h theta x, minus log of 1 minus h theta x. If y equals to 0, this will taking, and y equals to 1, this will be taking. And if y equals to 0, in that case cost will be this function. Now how to generalize these both? Now the question comes, how did you take this value? There is a lot of try and error which has been done to take this value. We'll be justifying this function also, but let's see just generalized part of this. This is generalized cost function here. 1 by m minus yi log of h theta x I plus 1 minus yi log of 1 minus h theta x I, right? And the goal is to minimize this cost function. How do we do that? use gradient descent as before we used, and repeatedly update these parameters. So gradient descent, what it will do, it will update the parameter. This one is nothing but gradient descent, right? We'll be using to update the parameters continuously until we reach to be cost to be minimum, right? Now in this we'll be justifying our cost functions. Okay, so suppose the cost has to be always minimum, right? Okay, so suppose y equals to 1, that is our actual output. Suppose I say, will this rain or not? And in the past what happened, it rained. And I predicted, suppose I predicted it to be, it did not rain, so I predict it to be 0. Suppose h theta x is 0. So log of 0 minus of log of 0, what you will get? Log of 0, it will be some undefined value, right? So we predicted it to be 0, but actually it's 1. So undefined minus, it's something, the cost is high. It's not equal to 0. Cost is nowhere approaching 0, right? So minus undefined of minus, we will take to undefined. It will be very much high value kind of, right? 1 by something. So cost is very high here. But if our predicted value is somehow equals to 1, in that case what will happen? This will be equal to log of 1 is 0. So cost will be 0 and it's equal to this actual value. So is it justifying our cost function? So suppose cost is 0, then y, the predicted h theta x equals to y, that is actual y. So actual value is equal to predicted value, and in that case cost is also coming to be 0. So this function is justifiable in case of y equals to 1. If y equals to 0, then what will happen? We'll use this cost function minus of log 1 minus h theta x. We'll be taking h theta x, that is predicted value, to be how much? 0. Suppose we predicted 0. In that case log of 1 is 0. So cost is 0. So this is also justifiable. Now how do we get this generalized form? You see this one. So suppose y equals to 1. In that case this term will go and this term will only survive. Minus of 1 by m log of h theta xi. And in case y equals to 0, in that case this term will survive as here. So this is how we generalize it. Okay. So in this graph also you can see. So if y equals to 1, that is actual value is 1. Yes, it will rain. It's it saying, right? In that case we have to increase our h theta x to be, the predicted value will be always between 0 and 1, as we saw, right? So it will be equal to 1. If it is equal to 1, what will happen? Cost will be also 0, and cost is decreasing as we are increasing this. If you take y equals to 0, if and if you keep on increasing this one, you will see opposite graph like this, cost will be increasing, right? In that case you have to take cost to be 0, right? So cost equals to 0 if y equals to 1. So h theta x equals to 1. Only then that is possible, cost is 0. And but as h theta x is equals to 0, cost is undefined. Like you see, if you take it to be 0, h theta x 0, then cost will be undefined, and that is not desirable. In case of y equals to 1, that will be cost will be shooting very high. In case if it is 0, it will be high, right? So that is what the justification of cost function. So this is our cost function generalized form. Now we have to minimize our cost function. This curve, this was already explained. This curve now you can see properly. So what we will do is, we'll be always getting some value between 0 and 1 using that function h theta x. H theta x will be giving us predicted value. So what we'll do, we will manipulate the output this to be either 1 or 0 based on some threshold value which we will decide later, right? Now how do we uh, minimize our cost? So we use gradient descent for that. D theta, d of j theta by d theta, something we do now, differentiation of it. So to find a minimum of anything, we differentiate value. So what will happen? X theta xi minus yi. This is our what? Error cost into x I we do, right? J is equal to 0, 1 to n. So we'll get some value and we'll apply it with some learning parameter, that is alpha is learning parameter. We'll reduce this one or like add something to this theta earlier and we get a new theta value. And with the help of that, we'll predict again h theta x. With the now this is updated theta t. Theta will be actually vector of theta will be updated and we'll get some new h theta x. With the help of that, we'll predict, we'll check again that cost is reducing or not. If cost is reducing, then fine, go ahead and update again until the cost is near about zero. It will not always be zero, but if it is near about zero, and in most cases it is coming, most examples it is coming, when we say that our model is trained, so gradient descent we use in this case. So only one change is what? The hypothesis function to fit to classification problem. And once we change hypothesis function, we have to change our cost functions as well. And once we change our cost functions, we have this new, this one, gradient descent. So coming to the end of the video, we'll be discussing examples or the applications of logistic regression. So in logistic regression, this is predictor, this is independent variables actually, and this is dependent variable. So in binary logistic regression, we have only two classes of to predict, like male and female. So now till now we were thinking of it is binary only, but we have multinomial also, in which we have many classes to predict. We can classify based on occupation, income, social class, and house ownership and all. We can predict if it is the lab or like LD Green, something party affiliation. With the help of ethnicity like white, black, how do we predict this class? With the help of income, qualification, occupation, and religion. With the help of these things, we can predict this. So we have used nothing but mathematical functions, mathematical tools to find it. And machine learning is nothing but maths. It's just that with the help of Python or like tools, various programming language, we do calculations based on these formula which were like given back earlier. So in the class 12th and all, we used to study and we used to think of like where is the use of these equations, where is the use of this function like y equals to mx plus c, where is the use of this exponential function, and now I'm using it, right? I'm making some algorithms, cool algorithms and all. So I'm thinking like, yeah, we used to study things and that's being used today. That's all, guys. That's all for today's session. Thank you very much, and do subscribe the channel for and support us in better ways. And if any video you want, you can ping us. We'll be having interview question series coming Sundays, so that you can have those videos also. That's all, guys. Thank you very much.